Welcome back to another episode of Codecraft, your ultimate guide to mastering AI and data science tools and libraries. I'm Alistair Louise, and today we're diving into the fascinating world of recommender systems. Get ready for a comprehensive journey through the theory, practical implementation, and everything in between using the powerful Surprise library. So let's get started. First things first, what exactly is a recommender system? Simply put, recommender systems are algorithms designed to suggest relevant items to users. These items can range from movies, music, books, and articles to products in an e-commerce store. The primary goal is to provide personalized recommendations that enhance user experience and satisfaction. Recommender systems are everywhere in today's digital world. Think about the personalized movie suggestions on Netflix, the curated playlist on Spotify, or the product recommendations on Amazon. These systems are essential for enhancing user engagement, driving sales, and improving content discoverability. Recommender systems come in various flavors, primarily categorized into three types: content-based filtering, collaborative filtering, and hybrid methods. Let's break down each one. Content-based filtering recommends items similar to those the user has shown interest in, based on item features. For example, if you like a sci-fi movie, it will recommend other sci-fi movies. Collaborative filtering relies on user behavior and preferences. It can be further divided into user-based and item-based collaborative filtering. User-based looks at users with similar preferences, while item-based finds items that are similar to those a user has liked. Hybrid methods combine multiple recommendation techniques to leverage the strengths of each method. For example, Netflix uses a hybrid approach that combines collaborative filtering and content-based filtering. Now that we have gone through different types of recommender systems, let's get hands-on with the Surprise library. Surprise is a Python library for building and analyzing recommender systems that deal with explicit rating data. It's simple yet powerful, perfect for our needs. Let's start by loading some data. Surprise provides a few built-in datasets like the Movie Lens dataset, which we'll use for our demonstration. First, we'll load the data and split it into training and test sets. We'll begin with building a collaborative filtering model using singular value decomposition or SVD. SVD is a matrix factorization technique that's highly effective for collaborative filtering tasks. SVD or singular value decomposition is a technique used to decompose a matrix into three other matrices. In the context of recommender systems, it helps in reducing the dimensionality of the user-item interaction matrix while preserving the essential features. This decomposition allows us to capture the underlying structure in the data, such as latent factors representing user preferences and item characteristics. Evaluation is crucial to understand how well our model performs. We'll use metrics like RMSE or root mean squared error and MAE or mean absolute error to gauge the accuracy of our predictions. Our results show an RMSE of 0.9435 and an MAE of 0.7429. The RMSE indicates how far our predictions are from the actual ratings on average, while the MAE measures the average magnitude of the errors. These values suggest that our model is performing quite well with reasonably low prediction errors. Content-based recommendation relies on item features to make suggestions. For instance, if a user likes a particular movie, we recommend other movies with similar attributes. Let's implement a simple content-based recommender using item features. We'll start by creating a small dataset of movies with their genres. Then, we'll use TF-IDF vectorization to convert the genre text data into numerical format. This allows us to calculate the cosine similarity between movies. Finally, we'll create a function to get movie recommendations based on the similarity. As you can see, the movies recommended for the matrix are Inception, Titanic, and The Godfather respectively, for which most have the same genre, that is, science fiction. Hybrid recommendation systems combine multiple approaches to leverage their strengths. For instance, we can combine collaborative filtering and content-based filtering to improve the quality of recommendations. Let's implement a simple hybrid recommender. We'll first build a collaborative filtering model using KNN or K-nearest neighbors, and then combine its results with our content-based recommendations. This way, we take advantage of both the user's interaction history and item features. We defined a function to combine content-based recommendations with collaborative filtering recommendations. The function first gets content-based recommendations using the method we implemented earlier. It then predicts ratings for the other items for a specific user using the collaborative filtering model and sorts them by predicted rating. Finally, it combines and returns the unique recommendations from both methods. Once again, using the hybrid recommender, the movies recommended for The Matrix and User 196 are Inception, Titanic, and The Godfather, respectively. Finally, let's make some predictions. We'll predict the rating a specific user might give to a specific item. The predicted rating by the KNN Basic Recommender for User 196 on item 302 is 3.7. And there you have it. We have built, trained, and evaluated collaborative filtering, content-based, and hybrid recommendation models using the Surprise library. Recommender systems are a powerful tool to personalize user experience, and with libraries like Surprise, building these systems become accessible and efficient. For a more detailed breakdown and additional insights, check out the accompanying blog post and collab notebook linked in the description. I hope you enjoyed this episode of Codecraft and found it insightful. Don't forget to like, subscribe, and hit the bell icon to stay updated with more awesome content. Thank you for watching, and goodbye for now.